Okay, horizontal translation, often called a phase shift, and you're going to have to learn that, okay? It's just a special terminology that we use when we're dealing with sine functions, cosine functions, and tan functions, and it's horizontal translation. It gets a special name called phase shift. So notice that we're inside the function here. We're inside this bracket. So when you're inside, it's going to be horizontal. Now, the formula has a negative. So if h is positive, if this h value is positive, it's going to look something like this. Y equals sine x minus plus 3. Well, that negative and that positive are going to go together to give you. So the h was actually positive, okay? But it looks negative when they give it to you. But the h was actually positive. So if the h is positive, it's going to move to the right. So if the h is positive, we're moving to the right, even though it's going to look like a negative here, okay? And if the h value is in fact negative, then it's going to look like this. So see how the h value is now negative? So that would actually look like this. Because a negative times a negative is a positive. So when it looks like this, we have to remember that the h value is negative. And when the h value is negative, it's going to be a shift to the left. Even though it looks positive here, to get that, the h value had to be negative. And we ran into this before with the vertex in a quadratic. Okay, so example 4. Sketch the graph of y equals sine x and y equals sine x minus 60 degrees. Well, let's think for a minute. It's inside the function, so it's going to be horizontal. And it's a negative here, which means that the h value must be positive. So this is going to be a shift to the right. And it's going to be a shift to the right 60 degrees. Let's take a look. First, let's sketch this guy. Y equals sine x. So we're going to sketch all the ordered pairs x comma sine x. So that's going to be 0 comma 0, 90 comma 1, 180 comma 0, 270 comma negative 1, and 360 comma 0. You just got to know those guys. You got to memorize them and know them. So let's sketch these. Let's make this 30, 60, 90, 30, 60, 90, 30, 60, 90, 30, 60, 90. Okay. Let's sketch our sine curve. So at 0, it goes nowhere. At 90, it hits a max. At 180, it hits 0. 270, it hits negative 1. 360 hits 0. These are the same as those points. Let's get our pretty little curve here. Beautiful. And that is y equals sine x. Gotta know it. Gotta know it inside out. Now, this y equals sine x minus 60 is going to be a horizontal shift. I know it's horizontal because it's inside the sine function, and it's going to be a horizontal shift. The h value is in fact positive, so it's going to be a shift to the right 60 degrees. So this curve has to move to the right 60 degrees. So that means at this point we'll move to the right 60 degrees. 30, 60. Right? Because if each one of these is 30 degrees, so that's 30 degrees, 60 degrees, 90 degrees. This one's got to move 60 degrees. Well, that's going to be 30, 60. So it's going to be moved over there. This one's going to be moved over 60 degrees. This one's going to be moved over 60 degrees. This one's going to be moved over 60 degrees. So 390, 420. It's going to be moved over to 420 degrees. So the curve actually looks like this now. Oh, I've goofed up. See how my scale is not right. This is, I went up 2, but I came down 3 here. That's wrong. This should come down to here. So this should actually only come down to here, and this one should actually only come down to here, which means that that should go like this, and that this black one should go like this. There we go. And we should be getting rid of, does not go down that low. And that does not go down that low. There we go. So what happened was this curve got moved to the right 60 degrees. Now, let's see what happens with our point notation. Since it's inside the function, it's a horizontal shift to the right. If you're moving to the right, all of my x values got moved to the right. So this is actually x plus 60 sine x. And I know that's weird, but you just got to kind of wrap your head around it. And what's going to happen is, so this one goes from 0. 0 plus 60 will be 60. This one is 90. 90 plus 60 is 150. 180 plus 60 is going to be 240. 270 plus 60 is going to be 330. And 360 plus 60 is going to be 420. All of the sine x's are the same. I didn't change the amplitude. I didn't change the range. I didn't move it up. I didn't move it down. All I did was shift it to the right. So it's still 0, 1, 0, -1, and 0. Let's see if that matches up. This is 60, 0. This point is 90, 120, 150. It is. It's 150, 1. This point here, 180, 210, 240. This will be 240, 0. This one over here was 60, 0. This one here, 270, 300. Hold on. This was, 240. So this 270, 270 was here. Moved over 30 was 300. 330, -1. And there it is there. And finally, 420, 0. So we can either use point notation if we want, or we can actually draw the two graphs. It's up to you, and in different situations we'll do different things. But what you have to be very careful is you have to realize that this is a horizontal shift. It's a horizontal shift to the right, which means it's going to change my x values by adding 60. Got to keep that in mind. So let's determine the period. The period of this did not change. Okay, so if we're talking about y equals sine x minus 60, the number of degrees that it takes for one complete cycle did not change. It's still 360 degrees. The only difference is we go from 60 to 420. The amplitude. Amplitude, if we look at this, we can tell it did not change from the amplitude of our original. And we know that our original has an amplitude of 1. Now your phase shift, that's a special word for horizontal shift. And the answer is 60 degrees to the right. So it was shifted 60 degrees that way. Range. The range didn't change. It still has a lowest value of -1. And it has a highest value of 1. And the equation of the horizontal axis did not change. It's still going to be y equals 0. Didn't move up or down. Okay, let's take a look at example number 5. So, we're going to sketch sine x, and we're going to sketch sine x plus 90. Now, plus, that means that the h value is negative inside the sine function, so it's horizontal. So the h value is negative, it's horizontal, so it's going to be horizontal, shift, left, 90 degrees. Let's try to do it using the mapping notation. So y equals sine x is going to be x comma sine x. And our new function is going to be y equals sine x plus 90. So what happens is the x values are moved to the left. So -90 sine x. So whatever x values we have here, we take 90 degrees away from it. Whatever sine x values we have here, they are the same here. A horizontal shift does not change the y-axis, only the x-axis. So it's going to start at 0, 0, 91, 180, 0, 270, -1, and 360, 0. We know that. That's always the case. This one will become 0 subtract 90, so it's -90. This one will be 90 subtract 90, 0. This one will be 180 subtract 90, 90. 270 subtract 90, 180. 360 subtract 90, 270. 0, 0. 1, 1. 0, 0. -1, -1. 0, 0. Let's just plot this and see where it takes us. Well, to do that, I'm going to go 30, 60, 90. 30, 60, 90. 30, 60, 90. 30, 60, 90. And I have to go to the left. So this will be -30, -60, and I need just a little bit more axis here. -90. Let's sketch this guy. So -90, 0. 0, 1. Let's go up 3 for 1. Let's go down 3. 0, 1. 90, 0. 180, -1. 270, 0. Let's put them together nicely. There, ladies and gentlemen, we have sketched that curve. We can tell everything about it. We can determine its period. Well, it goes from -90 to 270. That's still 360 degrees. Amplitude goes up to 1, down to -1. Amplitude is 1. Phase shift. Phase shift is 90 degrees left. Range. Well, it has a minimum value of -1. And it has a maximum value of 1. And the equation of the horizontal axis is right there. That's the horizontal axis for this curve. I did all of that without sketching x sine x. If I was to sketch x sine x, it would go here. And then you would see how the red graph is simply the black graph moved 90 degrees over to the left. Negative 30, negative 60, negative 90. Negative 30, negative 60, negative 90. Negative 30, negative 60, negative 90. And so on, and so on, and so on. All right. That's it for example 5. Let's come back and do example 6.